Alright, we're almost done with this programming example of chapter 12. 2 more sections left. And this one is working with environment variables. We'll improve mini-grep by adding an extra feature, an option for case-insensitive searching that the user can turn on via an environment variable. We could make this feature a command line option and require that users enter it each time they want it to apply, but instead we'll use an environment variable. Doing so allows our users to set the environment variable once and have all their searches be case insensitive in that terminal session. Writing a failing test for the case insensitive search function. We want to add a new search case insensitive function that we'll call when the environment variable is on. We'll continue to follow the TDD process, so the first step is, again, to write a failing test. We'll add a new test for the new search case insensitive function and rename our old test from one test to case sensitive to clarify the differences between the two tests, as shown in listing 12-20. So in this section, we're making a command line application, right? And we have the option of adding case insensitivity searching. We can do that via a command line option, as in the user types it in each time, or in this case we want to learn environment variables and how to use them in Rust, so we're going to do that via environment variable. An environment variable is something you set in your terminal for the terminal sessions, and they last or persist until the terminal session is over. And a lot of times they get reset at the very beginning depending on how you add it to your environment. Anyway, coming down here, we're going to follow the TDD process, which is test-driven development, and write our test first, make sure it fails the way we want, then write our code to make the test pass. And now I should get my editor. So we're renaming the first test, just so it's clear that this has nothing to do with the case insensitive part. And we're calling it case sensitive. Okay, but outside of that, it stays the way it is. And it's still in this block. Hold on, test. Nope, it's in a new block. Writing another test. Function, and we're calling it case insensitive. We're going to let the query equal Rust with some funky letters. And the contents looks the same? Wait, hold up. They changed these contents. Why is there they added duct here? Let me just verify. It looks like they changed it between one section and the next. Go back real quick, scroll down. Yeah, that last line was definitely not there. Pick 3, dot. Okay. They might have did it for a reason. We'll find out. Let's just add it. Copy. Paste. And then down here, case insensitive, the contents are contents equal what are these? Rust, safe, fast, productive, period, space, pick 3, period, space, trust me, period, well, it should have been period. let's end that. Okay. Next we do the assert statement. Assert equals, we're gonna have our vector, and it's gonna have 2 lines. Oh yeah, 2 lines, because Rust should match this line, and it should match the trust line, right? Yeah, those 2. Rust. Trust me that. Como. We haven't written the function yet, so it's not going to pop up. Search case insensitive query contents. So that's the second test. All right. Note that we've edited the old test contents too. We've added a new line with the text duct tape with a capital D, using a capital D that shouldn't match the query duct, the lowercase d, when we're searching in a case-sensitive manner. Changing the old test in this way helps ensure that we don't accidentally break the case-sensitive search functionality that we've already implemented. This test should pass now and should continue to pass as we work on the case-insensitive search. Okay, that explains it. So the reason, just reiterating, the reason why they added this line is because now we have a concept of case-sensitive searching and case-insensitive searching. So in the case-sensitive searching, we should still get just this one line, because this is the only duct that has a lowercase d that matches this letter for letter, case for case. If it was case insensitive, we would also get this line, which would mean that we've broken this functionality. The new test for the case insensitive search uses Rust as its query. In the search case insensitive function we're about to add, the query Rust should match the line containing Rust with a capital R and match the line trust me, even though both have different casing from the query. This is our failing test, and it will fail to compile because we haven't yet defined the search case insensitive function. Feel free to add a skeleton implementation that always returns an empty vector, similar to the way we did for the search function in listing 12-16 to see the test compile and fail. And yeah, let's do that. That's definitely something we should do. So the function name is, here we go, Control copy. The signature should be the same. So public function, put your name. You're gonna have a lifetime because we're dealing with references. You're going to have a query, which is going to be a pointer to a string, and you're gonna have contents, which is a pointer, a lifetime, and string. I'm going to return the same signature, so a vector that contains pointer to strings that have a lifetime. And then we can return an empty vector. And now our test should be able to run. And we should see one test fail, one test pass. That's not what we wanted to do. Cargo test. One pass, one fail. And the one that failed was the case insensitive. And the reason why it failed is because it had these two on the left, which is what we were expecting. And what it returned was an empty vector. Cool. Implementing the search case insensitive function. The search case insensitive function, shown in listing 12-21, will be almost the same as the search function. The only difference is that we'll lowercase the query and each line. So whatever the case of the input arguments, there'll be the same case when we check whether the line contains the query. Okay, that makes sense. So let's write that out real quick. So we are redefining query. Let query equal query dot lowercase, to lowercase. Let mutable results equal vect new, as it was before, for a line in contents.lines if, I put lin, if line dot to lowercase dot contains pointer to the query, and we're going to add it to the vector. Results dot push line, and we return results. And that should work as is. Let's verify that it works, and then I can explain it. Cargo test. 2 tests passed. These tests passed. Cool. All right, so what did we actually do? Let's put both of these in view so we can see both functions, the search and the search case insensitive. All right, so these functions are almost identical. The only real difference between the two is one is making things lowercase before we do our checks. So here we have public function search, we have a lifetime, we have a query, we have a content. The signature is actually exactly the same, given that the name is different. We take in query, and the first difference is that we make our query lowercase. We make our query lowercase because the casing doesn't matter. And because the casing doesn't matter, we can make everything the same casing and then search for if this query is in the contents or in the line. In order for that to work, we have to do the same thing with line. Make all the casing standard. So we make query to lowercase, and then when we're iterating over the lines, we make the lines lowercase. And then post making the lines lowercase, we check to see if that line contains the query. And this works because now everything is lowercase. If it is in there, we push the original line to the vector. The original line being prior to making it lowercase. So yeah, there's no to lower here. It's just the line. And then we return the results, same as here. First, we lowercase the query string and store it in a shadowed variable with the same name. Calling to lower on the query is necessary, so no matter whether the user's query is Rust, 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 or Rust, they all have different casings, we'll treat the query as if it were Rust and be insensitive to the case. Note that query is now a string rather than a string slice because calling toString creates new data rather than referencing existing data. That is something I didn't notice. So that's another difference between the two. A query is now a string, where this is a reference to a string or a string slice. I see. Say the query is Rust. As an example, that string slice doesn't contain a lowercase u or t for us to use. So we have to allocate a new string containing Rust. When we pass query as an argument to the contains method now, we need to add an ampersand because of the signature of contains is defined to take a string slice. That's something else I missed. So in contains, we passed in an ampersand query, so it pointed to the string, where here we just passed in query because query was already a pointer to a string. That makes sense. And the reason why we have to do that is because contains, by definition, takes a pointer to a string, or a string slice. Okay. Next, we add a call to lowercase on each line before we check whether it contains query to lowercase all characters. Now that we've converted line and query to lowercase, we'll find matches no matter what the case of the query is. Let's see if this implementation passes the test. It does. We checked. We ran it. Great. They passed. Now let's call the new search case insensitive function from the run function. First, we'll add a configuration option to the config struct to switch between case sensitive and case insensitive search. Adding this field will cause compiler errors because we aren't initializing this field anywhere yet. Eesh, I don't like compiler errors, but okay. I'll do what you say. So up here in the config, hub case sensitive, and we make that a boolean. Okay, that makes sense. Note that we added the case sensitive field that holds a boolean. Next, we need the run function to check the case sensitive field's value and use that to decide whether to call the search function or the search case insensitive function, as shown in listing 12-22. Note this still won't compile yet. Alright, so this makes sense. We're using this field as a mark of whether or not we should run search or search case insensitive. And we need to add this to the run function. So let's get to our run right here. And how do they modify run? They did an if config.caseSensitive. Put it there. Okay. So we now have results. Let results equal if config that case sensitive do search, which we already have the search down here, so you can just copy it, copy, paste. Else, I don't like the spacing. Let's move this out here so we can see everything. Else, we do the search case insensitive function. Search case insensitive, and we pass in pointer to config.query and a pointer reference to contents. And now we iterate over results and print that. You get removed. I misspelled results. Okay, so that's more or less the same. So yeah, we just use the boolean of case sensitive to check whether or not we should run search or search case insensitive. Cool. Finally, we need to check for the environment variable. The functions for working with environment variables are in the env module in the standard library. So we want to bring that module into scope with uStandardEnv line at the top of source libs. Then we'll use the var function from the env module to check for an environment variable named case insensitive, as shown in listing 12-23. Okay. So we're going to be working with environment variables, and Rust has a library or module for this called env. N is before R, so it probably goes up here. Use standard env. And now that we've imported this module, we can use it in our config to check to see whether or not the environment variable case insensitive has been set. And that's what we do here. So we do let case underscore sensitive equal environment var. Oh, it comes back with a result. Cool. And then they have the string case insensitive insensitive dot, I use it, is error. I'm not exactly sure what that is, but okay. Regardless, we see that it returned a Boolean with something we need, and then our Boolean should go into our config. And everything should work now. To show that it should work, we should be able to run the regular stuff like search for body and poem. And we got our 3 lines. Here, we create a new variable, case sensitive. To set its value, we call the environment var function and pass it the name of the case insensitive environment variable. The environment variable function returns a result that will be the successful OK variant that contains the value of the environment variable if the environment variable is set. It will return the error variant if the environment variable is not set. Okay. So here they're explaining environment var and that function, what it does. So we pass in the string. This string is going to be the name of the environment variable that we're searching for on our operating system. And if this variable has been set, it returns the value that it was set to. If it has not been set, then this returns an error. However, they're going to explain the next part is error, because that's at the tail end. Boop, right here. We're using the isError method on the result to check whether it's an error and therefore unset, which means it should do a case-sensitive search. If the case-insensitive environment variable is set to anything, isError will return false and the program will perform a case-insensitive search. We don't care about the value of the environment variable, just whether it's set or unset. So we're checking isError rather than using unwrap, expect, or any of the other methods we've seen on result. Alright, so that makes sense. So just to clarify, our config wants a Boolean. We want to have a Boolean that represents case sensitive. As such, the environment variable, the value of it doesn't actually matter. We just want to know if it's been set or not. If it's been set, then it has a value. If it has not been set, then it's error out. And that's going to be the result. That's what environment var returns, the result, right? And we could see that again if we just delete this portion. We get a result. However, since we only care about whether or not it's been set, we can check to see if it's an error. If there's an error, we know it hasn't been set. And if it's not error, then we know it has been set. And that just gives us the Boolean that we want. And that is why we do isError. Ta-da! We pass the value in the case-sensitive variable to the config instance, so the run function can read that value and decide whether to call search or search case insensitive, as we've implemented in listing 12-22. Let's give it a try. First, we'll run our program without the environment variable set, and with the query to, which should match any line that contains the word to in all lowercase. Okay? So let's do that really quickly. Run, we're not using body, we're using to. So we have 2 lines. Are you nobody too? How dreary to be somebody. 2 and 2. And that's what they have. Looks like that still works. Now let's run the program with case insensitive set to 1, but with the same query 2. And the way we do that, what? I'm not sure what. Oh, they have examples. Ugh. If you're using PowerShell, we need to set the environment variable and run the program in 2 commands rather than 1. I am not using PowerShell, so this looks funky to me, but it's good to know. If you're not using PowerShell, then you can probably run it like this, with the environment variable right before the command. I'll just copy it. Paste. And when we run it, we see that instead of getting 2 lines, we get 4. Because there's 2 capital 2's with T. Are you nobody too? How dreary to be somebody. To tell your name the livelong day. To an admiring bog. That's taken out of context. We've skipped some lines, but okay. And here are therefore lines. It matches. Moving onward. Excellent. We've also got lines containing to. Our mini-grep program can now do case-insensitive searching controlled by an environment variable. Now you know how to manage options set using either command line arguments or environment variables. Some programs allow argument and environment variables for the same configuration. In those cases, the program decides that one or the other takes precedence. For another exercise on your own, try controlling case insensitivity through either a command line argument or an environment variable. Decide whether the command line argument or environment variable should take precedence if the program is to run with one set to case sensitive and one set to case insensitive. As interesting as that sounds, I'm not going to do that. The standard environment variable contains many more useful features for dealing with environment variables. Check out its documentation to see what's available. And with that, we come to the end of this section. I hope this video was useful. Hope it was entertaining. If you like it, subscribe. Outside of that, peace.